Hi students, today we're going to be doing a flipped lesson on earthquakes. Through this lesson you're going to be learning some new vocabulary terms as well as get some new information that will help you with your upcoming earthquake building engineering project. I wanted to just bring your attention to your earthquake flipped lesson note sheet, and this is the note sheet that you should currently have. As you're going through the lesson, please be sure to answer the questions on the note sheet based on the information given. You'll notice that at the end you're going to be directed to an article, and there are some questions regarding your reading of that article as well. So be sure to pause anytime you need to and fill in the information in your note sheet. I'll be sure to tell you when you should refer to your note sheet. So here's an introduction to earthquakes. We've already discussed how the Earth is separated into many layers, and the top layer, also known as the crust or the lithosphere, is separated into tectonic plates. So what are earthquakes? Earthquakes are vibrations caused in the Earth's crust due to a release of energy in the ground, such as through volcanic activity or plate tectonic motion. You'll see on these two diagrams that the left side shows the tectonic plate boundaries of Earth, and on the right side is a diagram of earthquakes that have been recorded between 1980 and 2017. What do you notice about the earthquake locations? You'll probably notice that they clearly outline the plate tectonic boundaries, showing that there is a relationship of earthquakes along those plate boundaries. Please be sure to answer the information regarding the definition of earthquakes on your note-taking sheet. How exactly does the Earth move? Seismic waves is related to the motion inside the Earth due to plate tectonic activity and earthquakes. The energy waves that are released during an earthquake are called seismic waves. And in this picture they are being represented by red concentric circles. What's the difference between the focus and the epicenter? Be sure to answer this question by looking at the diagram and then answering it on your note-taking sheet. One main difference is its location. The focus is located below the ground, while the epicenter is located above the ground. Here's another difference. According to the diagram, do seismic waves originate from the focus or the epicenter? Well, let's look at the diagram. You'll notice that there are blue arrows emanating from the focus. This means that the seismic waves are moving or originating from the focus to the epicenter. This makes sense because plate tectonic boundaries are motions from vibrations inside of the Earth. So when the energy is released, it happens below ground, at the focus, and moves up towards the epicenter. Be sure to answer this question on your note-taking sheet. Let's talk about seismic waves. As mentioned, seismic waves are caused when earthquakes are released at the focus. And the seismic wave move in different ways, and there's different types of seismic waves. The first wave that is released at the focus is called the P wave, also known as the primary wave, and it causes a back and forth motion that is released from the focus up towards the epicenter. The S wave, also known as a secondary wave, is the next wave that is released at the focus, and it moves towards the epicenter. Notice that it moves differently and moves in a perpendicular motion. Then there are surface waves. A Rayleigh wave is an example of a surface wave, and it only occurs at the surface. And in this case, it causes an elliptical or a circular motion at the ground. Press this link to see an animation on how the seismic waves move. Let's look at the animation together. For the P wave, you can notice that it causes a compressional motion, and the particles move left and right. Play that one more time. If the left side were the focus, it would be moving through the ground to the surface of the Earth or the epicenter. Now let's look at the S wave, also known as a secondary wave. If the left side represents the focus, notice how it's moving towards the epicenter in a perpendicular manner. In this case, the particles would be more of an up and down motion, while the P wave was more a back and forth or a left and right motion. Now let's look at the Rayleigh waves. Notice that the motion is circular. These are called surface waves, again, because they only occur at the surface. And that circular motion is considered to be more damaging to buildings, as it is more difficult for buildings to survive that motion. So how exactly are earthquakes rated? Seismologists are scientists that use seismograms from earthquake monitoring stations to detect and assign a Richter Scale rating or value to earthquakes. Seismograms are the written record of machines called seismographs, and these are located all over the world. Here's some information regarding the Richter scale. The Richter scale is the scale that measures the energy released by earthquakes. It is a logarithmic scale that goes from 0 to 10. Theoretically, there could be earthquakes larger than 10. And you can notice that the lower the number is, the less damage there is, while the higher the number is, the more damage there is. You'll also notice on the scale that when you get to a 6, you'll have significant damage that starts to occur to buildings. Why do higher numbers on the Richter scale cause more damage? Well, as mentioned, the Richter scale is logarithmic, so it goes up by values of 10. So a 6.0 earthquake is 10 times more powerful than a 5.0 earthquake. Please be sure to write this information into your note-taking sheet. So let's look at an interactive Richter scale rating to see exactly what this means. When you're done with this video, come back to this slide. You'll notice on your note-taking sheet that there is a link for the interactive Richter scale rating. I'll click it so that you can see what the game looks like. But please be sure to play this game a little bit to get a better idea of how earthquakes are rated on the Richter scale and the damage that occurs according to the Richter scale. For instance, notice the damage that occurs at a 5. Now, if you think that's significant, be sure to continue to click up the Richter scale rating and see exactly the devastation that occurs on the higher rated levels. When you've done a couple of tries on the Richter scale game, be sure now to read the article called Powerful 7.1 Magnitude Earthquake Rocks Central Mexico. This article is a current events article and it's regarding the earthquakes that occurred in Mexico in September of this year. When you go through this article, you have two options. You could either read the article, or you can click right here to have the article read to you. But either way, be sure to read the article and or listen to the full article and then answer the questions on your note-taking sheet. These questions again are located at the bottom half of the sheet or the second page. Hopefully you've now learned some new information regarding earthquakes and you'll have a better idea of exactly how earthquakes are rated, where earthquakes occur, and the kind of damage that occurs at different values or different ratings of the Richter scale. For your earthquake engineering project, you're going to need to think about these things as you design a building that can survive higher levels of a Richter scale. Good luck!